So these are the basic operations in time domain, I can say. Next one, how I want to shift my signal in the vertically. So if I want to add a DC to my sine wave, how can I do that? So that you can call it as adding DC component to sine wave. How can I add a DC component to sine wave? So I will take the same sine wave and assume I'm going to add a DC of 5. I'm just adding a DC of 5. It's very simple. And whenever you add a DC, you are not doing anything on the time domain. You are going to do it outside the time domain. So I will not disturb what is there inside the sine term. Okay, so I'll be adding the DC component outside the sine. Okay, so now same way we'll plot. Can anybody say what will be the output for this stem waveform? Anybody predict how the waveform will be there for the stem waveform? Any guesses? Can you say how the waveform will be there for this last 2 lines of code? Whether the waveform will be right or left or top or bottom, can anybody say? What will be the impact of these 2 lines of code on the waveform? Adding a DC means you're shifting the waveform. So shifting will happen either in the positive y-axis or negative y-axis, right? And here I have given plus pi, so it definitely the signal should be shifted the positive y-axis. See here, this is the original sine wave and this is the shifted sine wave. So now see, I am adding 5. So this minus 5 plus 5 will become 0. 5 plus 5 will become 10. So signal will be from 0 to 10. The beautiful signal from 0 to 10. So I have shifted the sine wave completely to positive y-axis. So see there is no negative signal below the positive x-axis, so which means the signal is completely positive in nature. So if I want to do the reverse wave, I will add minus 5. If you add minus 5, the signal will be going downward. See here beautifully, it is existing from 0 to minus 10. Okay, it is existing from 0 to minus 10. So this is called as, you have a term called clamping. So all the television signals have composite, the TV signal is called as a composite, right? So there we usually clamp and send. So this, when you clamp it, the signal will be moving upwards or downwards from the reference x-axis. At the receiver end, they will use clamping as a reference signal to extract the original signal. See, the original signal is sine wave, but what is added? It is clamped to plus or minus pi. So when you remove this clamp, you will get back my original signal. So if you add plus pi to my signal at the transmitting end, at the receiving end, what I'll be doing? I'll be adding minus pi. So plus pi and minus pi will get cancelled. I'll get back my original signal. This logic is used in television signals, clamping and unclamping. Okay, I hope this thing is clear.